Hi Guru Prasad, how are you?
Yes, sir, I'm fine.
Okay, fine. So, why do you want to join ISRO?
Sir, currently I'm pursuing my master's in aerospace engineering in the second year from IIT Hyderabad. So I have keen interest in that field, and I'm also trained in that. I'm also getting the education in that field. That's why I'm about to join the ISR.
That's nice. And your BTech was on mechanical, right?
Yes, yes.
So, why did you join MTech in Aero? Any specific reason?
Uh, Sir, basically after BTech, at the time of my BTech, I was involved in the aero designing club of my college. So from that, I get exposure in this sector, and so I have developed a keen interest in that sector. That's why I joined aerospace engineering as master's program.
That's nice actually. So, can you give me how exactly a jet engine works?
Sir, basically jet engine works on different types of engines. The basically which are turboprop engines, then turbojet engines. Then now currently the developing phase are scram jet engines and ramjet engines. Basically the jet engine works on gas turbine cycle where we have compressor. Then there will be a combustor. There is a turbine, and then there will be the exhaust. So by using this, we will get the thrust.
Correct. So, in aeroplane we use jet engine nowadays, okay, everywhere.
Yes.
So, do we
Yes.
use IC engines in aeroplane as well?
Sir, for IC engines, there are different old kind of aircrafts there. So there, some of the aircrafts use IC engines, but we are getting high thrust by using the turboprop engines. So majorly we use turboprop engines.
Why do we? Are you sure if we use turboprop or turbofan engine?
Sir,
In com
in case of the commercial aircraft, we use turbofan engines,
Correct.
and in case of the
High
private
performance
jets or
fighter
small,
sites are,
yes,
yeah, right.
yes,
Correct.
yes.
That's correct. Yeah, so why do we use why jet engine offers higher efficiency than counterpart IC engine? What is the reason?
Sir, basically here we are talking about the air breathing engines. So there the air is as we are talking about the flying in the atmosphere. So their air is readily available. And while talking, the Brayton cycle gives higher efficiency as compared to the Otto cycle there. And here we are using the fuel we are using in case of the engine is the combustion will be external of the engine, so there will be high heat transfer at high temperature, so there will be high efficiency in case of the jet engines as compared to IC engines.
So you missed out one very important point. These are all secondary.
uh, the Sir, I guess for compression ratio there in case of IC engines the compression ratios are less, and here we are
Mm,
getting higher pressure ratios.
no,
And the main
okay, why do we have engines in aeroplane?
So to produce the thrust, high
Correct,
thrust. Yes,
correct,
yes, 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 yes. Yes, I got your point. There we want to convert the translation motion to
correct.
reciprocatory motion, but here we want high speeds and high velocities to generate thrust. That's why we use jet engine. Yes, right.
Correct. So in IC engine, we don't get thrust essentially.
Yes, yes, yes,
We
yes.
produce thrust using those turbine and propellers. So
Yeah,
it's totally different
yeah,
domain. But in jet
yes.
engine, we get thrust as an output.
Thrust.
Correct. That's right. So what's the fuel that is used in rocket engine?
Sir, basically in rocket engine we use different types of fuels. First of all, in solid rocket motor we use the oxidizer and the fuel as as a mixture, and we store it as a solid form. Then we use liquid rocket engines. In that we use liquid oxygen and liquid hydrogen, and yeah, these are the fuels we will use in the engine rocket motors.
Yeah, that's right. So let's say you want to cool some engine. Okay, because
Sir,
see, cooling
your
is very
voice is not
important in
coming.
any type of engine. क्या हुआ?
Hello,
हाँ, I should be audible. Yes, I am. I should be audible. Hello.
hello. Hi, yes, sir. No, no,
हाँ,
you're on.
ठीक है. So let's say cooling is very important in an engine. Okay,
Yes.
Why do we need cooling?
Sir, because here we are talking about the production of the thrust. So to produce it, we are talking about very high pressures, and
Actually, any type of
uh,
engine. It's not only jet engine, but any type of engine. We need
that
cooling.
is
Why do we need cooling?
Yes, because sir, the material out of which the engine is made up of, it has some certain limitations. So
Correct.
if the temperature go beyond it, then it will just cause damage to the system.
Correct. And also, cooling increases the efficiency as well. So
Yes, yes,
there
yes.
is that as well. But yes, material constraint, that's the most important point. So tell me, let's say you are an engineer, you want to design a engine and you want to design its cooling circuit. And for that, you need a coolant. So what are ideal
Yes,
characteristics
sir.
that you would wish the coolant to have?
Sir, the main ideal characteristic of cooling will be it should have high specific heat,
Mhm.
so that it can remove the large amount of heat. Then the major person it should be easily available, and the another one is that it should not cause damage to the environment. Like so the CFCs, we talk about CFC, they will cause damage to the environment. So we are now shifting towards R135 refrigerant, so which will not cause damage to the environment.
Correct. You again forgot one important point.
Uh,
These are secondary, okay? I mean, environment and all is cool, but still,
the it
it's
should
a
be high.
coolant.
It should be having high specific heat, and
Correct.
it
Very
should
correct.
yes,
Hmm.
and it should be have high boiling point because
Okay, fine.
yes, it should
Totally
have
understood.
yes,
Correct.
yes.
And
Uh, I'm not able to recall the
so it's
third
a
one.
coolant, so it will need to extract heat, right?
Yes,
How do a coolant extract heat?
and by evaporation
No,
process.
heat transfer coefficient. It needs to
Yes,
have a
yes, yes,
high
yes, yes.
transfer
Yeah,
coefficient.
yes,
Okay.
yes. You should have high heat transfer coefficient. Yes.
Correct. So I mean, mostly,
Yeah.
we have high specific heat and high transfer coefficient.
High heat transfer
The-
coefficient. Yes.
Correct. Rest of the things are managed, a little bit here and there. So
Yeah.
that's totally all right. Can you tell me some of the biggest jet engine manufacturers?
Sir, for jet engine manufacturers, we have Rolls-Royce, then we have Pratt& and Whitney, then we have General Electric Aviations.
Correct. That's nice. So let's assume, let me think. Hmm. Uh, let's say you are an engineer and you want to design a water tank.
No.
Okay. Now, because a building is very high, uh, let's say it's a very high, let's say 100 meter, 200 meter, something like that. Okay, and you have to take the water from ground level to the its terrace. Can you
Okay.
tell me what's your thinking methodology or designing methodology for that?
So first of all, to take that water from ground level to the tank level, I have to design only the tank, right?
Yes, I
Or
mean,
the complete pumping system.
yeah, complete pumping system. Just give me your
Okay,
thought
okay,
process.
okay. The thought process is that first of all we have to calculate the net head requirement for the to raise the fluid up to the highest point. So
Correct.
there we have to consider all the losses, and we have to calculate the net head required. And according to that, the requirement, I have to choose the pump for that. And by choosing the pump, I can definitely design the entire system.
Correct. Now tell me one thing. Will you pump it directly from bottom to top, or will you keep some breaks in between?
Sir,
Which
if
which one do you think
yes,
will
okay.
make more sense?
Here, I want to increase the head, so I will be preferring the series combination of the pumps so that I can get head. Because if I put it directly, so there will be more losses and the power requirement will be high. But if I put it in a series, then there will be power requirement is less. So I will go for the series arrangement.
Correct. And what is your restraining criteria, or your kind of stopping criteria for getting as much pumps as you want? Let's say, I mean, it's a 100-story building. You can't have 10 pumps, right?
Yes.
Because the cost
Uh,
will increase.
yes, sir. So for that, I have to calculate the net head. So and the head imparted by each and every pump. So I have to make the consideration of how much of increment of head I am getting by adding how much of power pump. So that will be the main limitation for me, because if I am getting only 1 meter of increment of head by adding a huge pump, then it will be of no use.
Correct. So, you must have traveled by flight, right?
Yeah, once.
It has air conditioning inside.
Yeah.
How does that air conditioning work?
So that works on the reverse Brayton cycle basically. And why reverse Brayton cycle is because as compared to vapor compression cycle, reverse Brayton cycle is less bulkier and its weight is also less. So basically we use it because in case of the flight applications we need less weight. So and here also the air is readily available. That compressed air is readily available, and this Brayton cycle can work on the engine the output that we are getting from the jet. So there we are using reverse Brayton cycle for
That is correct.
refrigeration purpose.
Uh, do you know how aeroplanes get their speed, their velocity?
For the initial thrust only by
No, no, no,
using the
no. Let's
thrust they
say
will get.
I'm flying in the air. I want to know my plane velocity. How do
Okay, to calculate the plane velocity we use pitot tubes. By
correct?
using pitot tubes we calculate the
So
velocity.
actually, P.2 is old generation. Now, we have a various of, GPS and all these things as well.
Yes,
But yes,
yes, that's
P.2
also
is the
there.
answer that,
Mm. But
uh,
the major fighter aircraft still use pitot tubes in front of it to measure the
correct.
velocities.
Why P.2 is so reliable?
Because it directly gives you the velocities and the calculation is also less because it directly gives you the static head, and from that we can directly calculate the value of velocity, and
Hmm.
so we will get the speed.
That's correct. Actually, that's amazing. Okay. Uh, fluid. Just 1 minute. Mm, so here is another question for you. Let's go back to the cooling topic. Okay, again. So let's say
Okay.
now you want to design a rocket. Okay,
Okay.
and now the cooling load will be even higher.
Yes.
Correct. I mean, you will have to cool it even more. So can you tell me some ways in which you could optimize or you could rise up that cooling mechanism, or you could optimize that cooling mechanism? What are your thought process on that?
So cooling mechanism for
Hmm.
rockets. Actually, haven't read about cooling mechanics for rocket, but I know the shielding that is done for the basically to secure the rockets.
Correct.
There we use the materials made up of composites, ceramics. As we know, ceramics have very high temperature sustainability. So
Correct.
there we use the ceramics. The casing that we have around the payload in the rockets, there we use ceramics and the composites.
Okay, that's nice actually. Okay, so I'll conclude your interview for now. Okay, I didn't march into fluid, thermo, and heat transfer as much, but yes, that was an amazing interview.